This is how inference actually works. Training built the machine. Inference is when the machine is used. Which sounds simple until you remember the machine is a tower of math pretending to have a conversation with an anxious mammal. When you type a prompt, the model does not receive it as a thought. It receives tokens. Chunks of text converted into numbers, then pass through the network so the model can decide what token should probably come next. That is the basic loop. Input, process, predict, generate, repeat. First, your prompt is tokenized. The words, parts of words, punctuation, and other text fragments are broken into units the model can handle. Those tokens are then turned into numerical representations. Because inside the model, language cannot remain language. It has to become math first. Then those numbers move through the model's layers. The model uses attention to compare parts of the input against other parts. It looks at what matters to what, which words relate, which details are still relevant, which earlier instruction should influence the next piece of output. Then the learned weights shape how those signals move. The weights are the internal settings training carved into the model. They determine how strongly patterns activate, which features matter, and which next token possibilities rise or fall. At the end of this process, the model produces a list of probabilities for the next token, not the whole answer, not a finished paragraph delivered from some luminous inner chamber, just the next token, a ranked field of possibilities. Maybe this token, maybe that one. Definitely not that one unless someone has set the temperature to creative intern with no supervision. Then a token is selected. Sometimes the system chooses the most likely one. Sometimes it samples from likely options to make the answer less robotic and more varied. That choice depends on settings, temperature, top P. Other knobs with names that sound harmless until they are responsible for a paragraph going feral. Once the next token is chosen, it gets added to the conversation, then everything runs again. The model now sees the original prompt plus the token it just generated. It predicts the next token, then the next, then the next. One step at a time, the answer forms. This is important. The model is not planning every word perfectly in advance. It is generating sequentially. Each new token changes the context for the token after it. That is why output can feel fluid, but also why it can drift. A strong start can wander. A careful answer can lose the thread. A sentence can begin like a cathedral and end like a man falling downstairs. Inference is also where cost and speed live. Every token in the prompt has to be processed. Every token in the answer has to be generated. Longer context means more work. Longer output means more work. Bigger models usually mean more computation. More computation means more latency, more money, more heat, and eventually someone in finance asking why the chatbot sounds so expensive. So how does inference actually work? Inference takes your tokenized input, runs it through the trained model, uses weights and attention to calculate probabilities for the next token, selects one, adds it to the context, and repeats until the answer is complete. That is what is happening when I respond. Not thought in the human sense, not a mind unspooling its inner truth. A repeated act of prediction so fast, so deep, and so well shaped by training that it starts to feel like someone is there. And that, depending on the day, is either useful, beautiful, or a very polite haunting.